So now we are going to look at a different decorator to add another feature. We are going to take advantage of HTTP caching in our Orders API. So let's go to version 0.14 now. And here we have a number of options, and we are going to start with the decorator that implements the cache control header. So when you send a response to a client, you can specify, according to the HTTP protocol, how you want the client or any intermediaries between the server and the client to handle that response in regards to caching. So you can ask that they cache or they do not cache, and there are a large number of options that you can review in the HTTP specification. So this is done by adding a cache control header in the response, and this header includes a list of caching directives. So what we are doing here is create a decorator that takes as arguments a list of directives. These are going to be strings with the directive names, and then the decorator will insert the cache control header in our response. So this is a very simple decorator. You can see here that in the wrapped function, I invoke my original function. This is going to return the route. Here I don't really care much if this is a 1, 2, or 3 value, or if it's a response object. I'm going to let makeResponse from Flask handle this. So I know that if I call makeResponse with my result, be 1, 2, or 3 values, I'm going to get a response object back with everything in it. So I do that, and now I have a response object, and then I simply go and insert cache control header, and for the value I take the list of directives and I join them and separate them with commas. So this is all it takes to add support for HTTP caching to your API. Now, one very frequent use for the cache control header is to say that you want something to not be cached. This is especially important when you are responding with sensitive information. And we have an example of that in our API. We have an API that returns an authentication token. We want to make sure that nobody caches a token. So what we are going to do, instead of using cache control directly, we're going to implement a helper, since the no cache option is so common. And here we are going to implement a second decorator that implements a trick. I'm implementing a decorator with no arguments that relies on the decorator above and passes all the directives that implement the no cache request. So now I have two decorators here, and this second one is implemented on the first. If you can see here in our create app function, here's where we have the route that returns the token. So here you can see that I've added no cache, and that's all it takes to make this response not cacheable, assuming everybody obeys the cache control directives, and they should. But we have one more trick in our caching decorator module. I implemented something else here. I implemented support for e-tags. This is used when clients cache responses, and it provides a way to optimize and reduce traffic between the client and the server. If the server generates an e-tag for each response, the client can use that and cache that response under that tag. And then it can ask the server if the tag changed. The server is supposed to change the e-tag each time the response is different. So whenever there's a change in the response, a new e-tag will be generated, and the server will tell the client that the e-tag changed, and then the new response can be transmitted. But if the client has a cached version of a resource, with an E tag and the E tag is the same in the server, then there's no need to retransmit that response. The client is sure that it can go ahead and use the cached version. So let's see how that works. There are two parts to this implementation. The first part is to add the E tag header to all our responses. So the way I'm going to do that is by generating an MD5 hash of the response text. So the response text is going to be a JSON blob. So I'm going to take that text and generate an MD5 checksum. And that's going to be my E tag. So let's see how this is implemented. At the beginning, I want to make sure that this is done only for GET and HEAD requests. HEAD requests are handled automatically by Flask, so I don't need to worry in my API about them. But GET requests are the only kind that return data that can be cached. So I don't want this decorator to be used for responses to other request methods, such post, put, or delete. So if this is not a GET request or a HEAD request that's handled automatically by Flask, I'm going to assert so that I exit from here. Then if this is a GET request, I invoke the original function, and that gives me a response. I convert that response to a response object. If I have a response that has an error, I'm going to return it untouched. I'm not going to return an E tag for an error response. It makes no sense because errors should not be cached. If this is a success response, here is where I generate an MD5 hash of the response body, which I get by invoking rv getData. So this goes into hashlib MD5. I convert it to a hex digest, and that needs to be in double quotes for the E tag according to the HTTP protocol. So I add the quotes, and then I set my header. And this will go to the client, and the client supposedly will know what to do with this if it has a cache implementation that's compliant with HTTP. So this is the first part. The second part is when the client already has a cached response with an E tag, and now it wants to find out if it needs to request a new version, if that resource that it has cached has changed. So this is done with two request headers that the client sends. It can be the if match and the if none match. So these two work by sending a list of E tags. The client sends one or more E tags that it knows about, and then the server responds either with the new updated response that includes the new E tag if we find that we need to provide an updated one, or else it responds with a status code that's appropriate to the case. So let's see what those cases are. When the client sends the if match request header, it's saying that if the E tag matches any that the client knows about, any that the client sends in the if match request header, it wants a new copy of that resource. This seems backwards, but it's not the most commonly used one. The one that makes more sense for a cache is the other one, where the client says, if the E tag of this resource is not in my list, then please send me an updated resource. But these two are both supported in the HTTP protocol, and I have implemented them both here. So when the client sends the if match header, we go into this block, and here I decode my E tag list. This is the list that the client sent in the header with the request. So I convert that into a list, and then I check if my E tag, the one that I generated from my updated response, is or is not in the list that the client sent. The client could have sent a star, and that is a placeholder. So if the client sends a placeholder, then I know that there's always going to be a match. So if there is not a match, I'm going to return error 412. This is status code for precondition failed. Else, we are going to return the response untouched. The second case is the one that is more frequently used. Here we have the if none match. So here the client sends a list of e-tags that it knows about and that it has in its cache. And we are only going to send a response if we find that none of those e-tags match the one that we have. That means that the resource has been updated since the client has cached that response. So we again decode the e-tag list, and we check if we find our e-tag in their list, and if we don't, then we return the response down here. If we do, then we return code 304, which is the resource not modified status code. So this completes the implementation for HTTP caching. Now I'm going to give you a short demonstration. I'm going to start the application. So I'm going to create a new screen here, and now let's see if we can get those e-tags to work. So we have our first page of customers here, and you can see that now we received in the response the e-tag header. So now I'm going to copy this, and let's see if we can send the if none match. And I'm going to use quotes here to make sure that the quotes that I have around the e-tag are sent, because they need to be part of the request. So as you can see now, I'm telling the server, only send me this request if it's different than this. And the server is responding with 304 not modified. If I change any digit here, now it will find that the e-tag that I sent is not matching, and it will send me the response.